My name is Magnus Härlin, and I work for a company called SpeedLedger in Gothenburg, Sweden. So it's a privilege to come here to France and eat all the good cheeses. I'm going to talk about Scala for Java developers. And even if you're using Scala now, I hope that you'll get some takeaway points from it, but it's mostly for those who are not using Scala and want to start using it. And you'll also get some selling points so that you can try to convince your company that, yeah, we should really start using Scala. And you can get the slides from my GitHub and just do the same presentation again if you like. Feel free to steal anything. How many of you are using Scala in your day-to-day work? About half. That's really good. And the other half, are you using Java? Yeah, about. Great. You've found the right place, I think. OK, so why would we use Scala? The first and foremost is obviously because all the hipsters do. One of the main reasons is that it's really easy to read, and it's nice and concise. And I think you've all heard that you usually read code at least 10 times more than you write code. So that's why readability is easy. And with more concise code and expressive code, it's easier to follow the flow so that you don't get lost because you have to go to another class and to another class and into a function. And then when you start going back, it's like, yeah, and where was I in the flow? A lot of that is like the normal way that you work in Java. But in Scala, with a much more concise and expressive syntax, and that you can have functions within your functions, makes it much easier to just read and follow. So you start at the top, you go down to the bottom, and you have the context with you all the way. So what makes it more concise? To define a variable in Scala, you can type val, and then the name of the variable. And val means that it's going to be immutable as well. You can use var if you need mutability, but it's not recommended. But every now and then, on edge cases, you might want mutability. And var might also be something that you need to use if you want to use some Scala libraries or something else. The interoperability between Scala and Java is great. So you can use any Scala libraries from any Java libraries from Scala and the other way around. If you do libraries in Scala, there might be some small things that you need to think about, like the specific things to Scala might not be perfect as the API towards the Java. But other than that, it's fine. So you can just take a part of your project, do it in Scala, and then use the rest that you've already made in Java. So it's a nice stepping stone to get into Scala and functional programming. So if we add the type and give it a value of 5, we see that, yeah, we get a variable of a that has the type int and then value 5. So we can do the same thing, but we can remove the type, because Scala has type inference. So there are a couple of characters that you don't need to write, and especially a couple of characters that you don't need to read, because it doesn't really affect the flow. You'll get exactly the same result. And if we look here, you see the little Scala prompt in the start. That's from the Scala REPL. It's read, evaluate, print loop. So if you go into bash or whatever shell you're using and just type Scala, you'll get the Scala REPL, where you can type any Scala expression, and it's going to be evaluated straight away. If you do it in the application context, then you can import your classes and just run small bits of your code at a time. So it's a really handy way if you're prototyping and trying out stuff. If we want to define a function, we'll just say def add, and the function takes 2 parameters, x and y. And then we'll add the brackets. No, we don't need that. If it's one expression, we can skip the brackets. and then we'll add the return statement. We don't need that, because the last thing that was evaluated within the function is going to be the return value, and then we'll add the implementation, x plus y. So here we have a complete function that does addition for us. And compared to what it would look like in Java, I think this is nice, beautiful, and really readable. And that's a good thing, because even if you're coming from a Java background and you start reading Scala code, you usually understand almost everything straight away, because there isn't that much strange syntax around it. And the thing we get back is a function that takes 2 parameters and returns an int. So this is the function signature. And if we want to use it, we just take the function name, pass the parameters, and we'll get back an answer. Imagine that you're sitting, having a great time, you're in the flow, working on your next feature, and then suddenly, boom, you got a null pointer exception in production. Has it ever happened to any of you? I think all. It's happened to me a lot before I started using Scala. Now I think I can count on my fingers how many times it has happened since I started using Scala about a year ago. Because instead of null pointer exceptions that this might give, like you call the getDB user, and you think that you're going to get something back, and you start using the object that you get back, and if you didn't get anything, you'll get the null pointer exceptions. To mitigate that, you can use the option instead, which basically so that you tell the user of your function that you could get the value back, but you might not. So just wrap the user object in an option. So you're either going to get back some value or a none value, which you can check for. And we're going to get back to the option type more, because it's so important. Does anyone recognize Michael Feathers? He wrote in his book, Working Effectively with Legacy Code, that OO, object orientation, makes the code understandable by encapsulating moving parts, and functional programming makes code understandable by minimizing moving parts. Scala is a multi-paradigm language, so you get both object orientation and functional programming, which means that you can minimize the moving parts, and the parts that you still have are easy to encapsulate, because you can still use object orientation in Scala. Have you ever met the spaghetti monster? Especially when you start debugging code that's more than 3 months old. It usually hits you in the head or throws meatballs at you. And mutable state is the new kind of spaghetti code. Because what it does is that you'll get those sort of hard to find side effects. Like if you pass an object in to fetch something, and then that object is updated within the get function or a place where you don't expect it, it's really hard to find a bug and know why it's happening. So that's why you should try to avoid mutable state as much as possible. In Scala, it's quite hard, and we'll get back to that several times. If we have a look at this class, it's fine if you can't see it. I can just tell you quickly that it's a user that has a list of orders, and the orders has a list of products. And just to read this, it's going to take a while, obviously. But let's see how it could look in Scala. And since we don't want to use mutable state in Scala, we're going to do it immutable. And we could have done that in this Java class as well, but I'm going to get back to why that might be hard. In Scala, we have case classes, which means I want an immutable class that has lots of extra functionality. And we'll give it a name and tell it what properties we want in the class. This was the first class. It's done. OK, let's add the product and the order. That's really easy. And you see the sequence, that's another word for list in Scala. So you could write list as well, but the least common denominator is the sequence. So, and the sequence is lazy, so then you can choose in your implementation if you want it to be lazy or if you want it to be eager loaded, which gives you more flexibility. And to use this, it's basically the same, but again, you can remove the new keyword. You don't need it. And back, you'll get the full list. If you wanted, you could have written all of this in one line. Now I put it into 3 different variables. And compare this to the last slide. Yeah. All of those who haven't been working with Scala, was it easy to read the class definitions? Get the feel for the structure of the program? I would say so. So let's get back to the options. Scala, it's basically Scala's way of giving you type level support for handling null values. And to create an option, you could either use the sum value. So this means that we'll get a string of option, or you can use the none value. So the option value always has 2 different paths. One is the sum, which has a value, and the other one is the none, which didn't have a value. And when you assign a variable, an option value, so in this case, we randomize, so every now and then this is going to have some scalaIO, and in other cases, it's going to have the none value. And when we want to use it, we'll just take the variable and add get or else, which means that if it did have scalaIO, we're all happy. And otherwise, we'll default it to a normal working day. And this is a handy way to handle the nulls that you get back. Case classes, they're immutable. They have a concise syntax for creating the objects. And then they have all the nice comparison things that you want, like equals and the hash code. So say that you have a case class that has like 10 properties, and you instantiate 2 of them. If they have the same values and you compare them, it doesn't matter if you use the dot equals method or the equal signs. They're going to give the same result. If it's the same values, they're going to return true when you compare them. And that's very, very powerful. So in Java, you'd probably override the equals method to get something like that. And then when you add another property and you forget to add it to the comparison, you'll have another little subtle bug. And we'll get into the extractors, creators, and copy. So let's have a look. We'll create a case class with the user again. And to instantiate it, we can use new, as you recognize from Java, user, and then just give it the option or the values. We can use .apply, which does exactly the same thing. It gives us back the same result. Or we can use the syntax that we used last time without anything. So this is the most concise syntax, and it's really nice and easy. And whenever you see the apply method used anywhere, you know that you can just remove it and you'll get exactly the same result. OK, so say that the user has plenty of properties, and the only thing that you want to do is update the first name. In Java, if you would have made something immutable, you would have like 10 constructor parameters that you needed to send in from the last object to the new object and just change the one. In Scala, you can use the copy method. And then it's going to keep the same values on all parameters except the ones that you explicitly change. So in this case, we're going to get back an object with Magnus IO. So it kept the last name and changed the first name. And you can then add more than one parameter to the copy function if you like to change more parameters of the case class. This is really, really powerful, I think. And it's why it makes it so easy to work with immutable values. Pattern matching. Stick the right thing in the right hole. It's basically matching on a lot of things. So it can do match on types, it can match on values, and it can filter stuff away for you, and you can extract stuff from the objects that you're looking at. So if we care about the privacy of our users, and we have an optional surname, and we want to match on it, so we'll create a function which matches on a user. And the match statement is just match, and then you have the brackets. And in there, you create cases for each match that you want to use. In this case, we have the user, which means that we want an object of the user type. We're matching on the type. And here we use an extractor. So we extract the value from the first name into a new variable called fname. And then we say to it that don't match anything, or only match if the surname doesn't have a value. So we're filtering away everything that has a value for the surname. So what we get is that we get the first name but no surname, and we can type that. The other case, we're matching on the user type, underscore, is if you don't care about the value. You tell it that don't filter anything away, accept everything, but you don't need to extract the value. Just leave it there. And here, we do double magic. First of all, we're telling it to match on the value, that it has to have some value of the option. And then we're using the extractor first from the case class to get the option value, and then from the option value to get the actual value of the option and put it into the new variable. So we're basically doing 2-3 things at the same time. And this will only match if it's sum. And we assign it to a new variable called lname. And then we can type the last name that we got. And there's plenty more that you can do with the pattern matching. But this is sort of a nice basic example, I think. And in the pattern matching, we have the case keyword. It's not to be, you have the case in the case class as well, but they have completely different meanings in the different contexts, and I have nothing to do with each other, or they don't have too much to do with each other because they're in different contexts. Trait is basically like an interface and an abstract base class at the same time. And you can use it for inheritance, and you can mix several traits together if you like. You can either have them just as a common denominator. So if you have several types of users, you can say that, yeah, they all extend person. Or then you can have like an enum, which doesn't have a value in it, but also extends person. So can you imagine any place where you had enums in Java, where you actually wanted to just have a little bit more information in some cases, but not all of them? That's what you're able to do with traits. And in traits, you can also implement functions and other stuff. But this, for the object orientation part, this is really, really handy. And if we want to match on this, we do the same kind of pattern matching. And we say that if we get a customer, and it matches true, that it's a VIP customer, then it's going to take the first case. If it doesn't match, it's always going to go to the next case. And in this case, it's going to be, it's not a VIP customer. If we want to match on the case objects that don't have any type, we'll just type the type, and we'll get the result and a match there. And what about all the other cases? If we don't care, if we want a default case, we add underscore. And it gives the same meaning here as when we were extracting variables. It's not going to discard anything, and everything else is going to go into this case. If we were doing a complete case matching against all the cases and we didn't have a default case, then we would get compiler warnings if we didn't match all the cases. So if you add something new, you'll get a compiler warning, and your IDE will probably tell you as well that you haven't matched all the cases. Do you want to? Partial functions is handy if you want to do different stuff depending on type or depending on different situations. In this case, we're just making everything. We take a sequence of any, where we have an int and a string, and we just take them out. We don't do anything with them. So what happens here? We get an error. We get a match error. That's because we haven't matched all the cases that we have had in our array. And it might be something that we didn't think about, or it might be that we wanted to filter some of the values away. And to do that, we could have used the collect instead. Collect is a really handy function. It basically lets you choose whatever you have matches for and also do a map on it. So in this case, it's going to disregard the Boolean value because we don't have a match for it. And these partial functions that we have here with the cases, they can be combined. So you can create different variables with partial functions and just add them together until you're happy, which gives you the nice composition. When we looked at map, we're going to look at map again. But the main thing, when you want to use partial functions, you use brackets instead of parentheses. So when we're using a map here, we use brackets, basically telling it we're going to give you partial functions and try to fit whatever values you get into these partial functions and see if you get a hit. So with all the concurrency that we want, obviously, it's a high-performing system, we need immutability. And if we made everything according to how you're supposed to make it in Scala, immutable, there shouldn't be any problems with just adding another lane, a processor, more memory, and parallelizing whatever you have. I'm not going to go into any code examples, but there are plenty out there, and you can use the tasks and the futures or different libraries for it. And because it's immutable, you're not going to get any of the threading issues and sort of subtle bugs there either. So it opens up for easily being able to expand your program. Functional and composition. Don't iterate and mutate, transform. That's definitely the main thing, I would say. When you're working with data, instead of having loops, try to transform it. And you can pass other functions to functions. We saw that a little bit with the partial functions. So say that we have a function that returns the length of a list of strings. In Java, it would have looked something like this. I know that there's streams now, so it could look a little bit better. But this sort of was the way to do it before. And I don't know, it takes a while to read. It's kind of hard. You're so good, so you don't have any problems with it. If you did it in with the streams, it could look something like this. There might be a more efficient way, but at least we get it as a one-liner. In Scala, I think it's beautiful. We use max by, and we tell it what property we want to use to get the highest value, or the longest string in this case. And I think, however you do it with the streaming API, you're definitely not going to get down to this conciseness. So, with a map, we have Vive la France and scalaIO in a sequence. And when we create sequences and lists in Scala, you just need to add it like this. It's really easy to create new lists. And to get the length of the list, we can use s.length. And we define a function for it. And the signature of the function is going to be that the name is string length. And it takes a parameter of string and returns an int. And we can define functions in different ways. We could also assign it to a variable. And this is going to have the same signature as the one before. And that's important when we get to the next part. And this is obviously one way that you could pass functions around, because it's easy to pass variables around. If you look at the definition of map, you see that it takes an A, returns a B, and traversable basically means that it's a sequence that you can go through. If we take it to our example, we can just change the B to being int, so that we accept a string and we return an int. And if you look at the signatures of the functions, you see that they take a string and they return an int. If we use a lambda function, we can type it out like this and pick out the length. We can also use the shorthand with underscore, which basically means that the value that you get in, and then you just dot it. So it's exactly the same thing as above, only you don't need to have the arrow. Or you can just tell it to use a function that has the right signature. In this case, takes a string, returns an int. Or you could use our second function, that's a variable, that you just pass in, and you'll get exactly the same results. Flatten. It's a way, if you have a sequence of sequences, so say that you have like a customer that has orders, and then you have several customers and you want all the orders, then you would have a sequence within a sequence. And Flatten removes one sequence from it. So in this case, it would remove the outermost sequence. Sorry, I'll rephrase that. In this case, it's going to remove all the sequence and parentheses within the outermost sequence. So what you'll get back is scalaIO, I love France, Lyon. What about the middle sequence? Well, it's empty, and it's going to remove all the sequence and parentheses. So what we get back is just that. It removes all the values that we're not interested in a really nice and easy way. Can somebody tell me what's going to happen here when we use it with option types? What are we going to get back? Very nice. scalaIO and Lyon. Exactly. Because the non-values is going to disappear. And the sum as well because it's just a wrapper. So it removes the wrappers and returns the values. And what do you get if you compare flatten, or if you combine flatten and map? Flat map. Whoa! And how can you use flat map? So say that you want all the products, and you create a nice loop, and then you have a mutable list, and then you add stuff to it. Ooh, let's not do that. Let's flat map. You can see. I promise you, it just says products, and then there is an end bracket. So what we're saying here is that you have the orders object, and then you take the products from it, and then you have the list in the list. So we want to flatten it, and we want to be able to say what we wanted from the orders object. So that's why we use flat map. Flatten and map. And here we get one part, but what if we have many users and many products, and we want to get them all? Well, obviously, we could do a flat map within a flat map and get all the values. It's quite nice, but not as nice as the for comprehension. The for comprehension does flat map for us. So in this case, we very easily pick out the users, and then from the users, we pick out the orders. From the orders, we pick out the products, and then we just say that, yeah, yield all the products, basically return all the products. And the nice and handy thing from this is that I think it's much more readable than the flat map above, because when you start nesting things, it's not readable anymore. Okay, things that might confuse, or at least that confused me when I started with Scala, is multiple parameters. It doesn't look too bad. You often see function definitions like this. It means that it takes 2 parameters. It's just that it takes it in multiple parameter sets. So when we implement the function, we do it the same way as we would have before. We get the same result. But what we can do is basically create a new function. So what we do here is that we create a function which we name add5, and we supply the first parameter. And the function that we get back now is basically one that takes one more parameter, because we needed 2, we supplied 1, there's 1 left. Okay, so the result, if we use the add5 function and add the last parameter, it's going to give us 8, because the first parameter we supplied was 5. And it's a handy way to supply some of the parameters, and then maybe the last part of the implementation can supply the last one. So if you want to reuse a function with just some parameters, this is a really handy way of doing it. But the most common case for it is the one that's not so obvious. You often, if you look at the function definition, you often have implicits. And that means that you can still supply a parameter for it, no problems. We supply 1 and 2, just like we did before, no difference. But doesn't implicit mean that you don't have to supply a parameter? It's implicit. It's going to take an int. You might think so. No. Could not find implicit value for parameter y int. So what it does is it starts looking in the scope, in the class or in the function or in the namespace or package or whatever where we are. And it looks, have you given or have you defined a value that's implicit of the type int? To do that, we just add implicit in front of our declaration, and we have the implicit value. If we run the function again, add 3, we'll get back 7. The most common use case for this is when you're working with tasks or other things that want schedulers or something that probably you have a global one or you might define one much higher up. And you can always supply a parameter for it explicitly, but you don't have to, because if you've done it before, then you're fine. And just like Marcus told me on the dinner yesterday, the most common thing when you have like execution context is that you pick the default one on the very top of your program. Don't do that. Then Marcus is going to chase you. It's also used a lot in like if you want to encode and decode JSON, because you'll probably have your codecs somewhere in one place and maybe not in the implementation, and then you just need to import those, and they're going to be available. And it reduces code again, so that it makes the code more readable, because you're probably not that interested when you're reading how the program works to know exactly what decoder it uses. But if you do have or get a problem in the decoder, it can be a little bit tricky to find out what decoder is it using, because you can't see it in the code. So it has both pros and cons. I hope you're starting to see the light. And I definitely hope that you go back to your companies and your day-to-day work and try to start using Scala and teach everyone else at the company on how to use Scala. Because it's hard to pinpoint like one thing, but with all the small things together, it's going to make a huge difference. And the Scala code is really readable for everyone. And the Scala code you write in the beginning isn't going to be the most beautiful one. But it's also a very easy way to get the Java developers to get on the train and start using it and start seeing it. And then when it evolves and they go back to the old Java code and looks at it, they'll definitely realize that, yeah, I never want to go back to that place again. From here on, I'll go with Scala. Thank you. The slides and everything are available at my GitHub account. And if you have any comments on the sessions or you have questions, you can either come and ask me or just send me a tweet at Magnus Härlin. Do you have any questions? No questions at all? You're kidding, right? OK, yeah? Oh, yeah. Yeah, so the question was how to make Scala to work more like a DSL. And the way to do it is that you can define variables with sort of understandable names that take parameters. So if we go back to the slide. Here, for example. So if we go back here, then the same, oh, no, this looks really nice on my computer, but not on yours. Here. If we look here, we can see that here we defined the add function, or add5 and add5 function. And the add5 function takes one parameter. And with the infix and postfix in Scala, you don't need the brackets. So you could use some kind of like understandable name for it and just write it out. And then the value that comes after, it's going to take as the in parameter. So in this way, you could define several functions, like, I don't know, maybe you want to have an add function so that you can have add, and then you add one parameter, 5. And then you could define a plus, which takes another parameter. And then you could have a sum function that basically takes those and gives you the result. So what it gives you is that you can define several small functions that takes the parameters that you want and then combine them together so that the next one will take the results of the previous ones. Did that answer your question? I don't have any examples now, and I think it's it's a whole talks, definitely. And another common question, since nobody asked it, is like, okay, so yeah. If you want to change a value in the case class, you use the copy function. So when you've assigned, initiated the case class and assigned it to a variable, you take that variable and just do .copy, and then you can change the properties that you like within the copy function, and it's going to give you back a new case class with the updated values, and the old one is going to stay exactly the same. So the copy function, yeah. It works with regular classes as well. And yeah, if you provide an apply. Another common question that I've had before is that, yeah, so now when I want to start using this, I probably want to do some kind of web framework or like web service. What framework should I use? What's the easiest one? And there's plenty out there, but the easy and common ones or most popular ones is probably Play, because then you'll get like both the API side and the HTML side of it, and there is plenty of documentation on it. So when you start playing with it, use the Play framework. Any more questions? Yeah?
Could you say a bit more about the applying?
Yeah, sure. Whenever you have, when you implement apply function, you create, instead of creating a class, you create an object with the same name as the class, and that's called companion object. And in that companion object, you can define the apply functions, which can take different parameters. So if you have a case class that takes first name and then the last name is optional, then you could make another apply function that only takes the first name, and then you supply the last name, for example. Or you can take any or more parameters if you're actually calculating stuff. So the companion object is something that you can use to instantiate the class or the case class that you have. And you can also add any functions to it. So if you have like calculations that you want to use in your class and you don't want to have it in the case class, or you want to be able to use it without instantiating a class, then you can put them in the companion object instead. And also you can implement companion objects for stuff that maybe you haven't made, but you want to be able to initialize them easily and use them in your case, in your match and case. Thank you.